While learning most of the computational languages, people often try to print the particular printing statements that is hello world. This trend is followed over a decades. Similarly, in the book of machine learning, the chapter begins with the most popular model, maybe the hello world of this field, linear regression. Here is the high level overview of the code, but believe me, in the end of the video, you know how the execution is done under the hood. So for the intuition, consider you are learning the ride the bicycle. From that, you can able to know that if we lean left or right, we may fall down. At the same time, if you push the pedal faster, then you may get a balance. These things are gained through the practical experience of riding the bicycle. Similarly, the data set is used to feed the knowledge and the experience for the machine learning models. In the machine learning lingo, the features are said to be the typical inputs and the targets are the things that the model had to predict or model have to predict. Either they are discrete or continuous values. If we see our data set, the rooms are the features and the prices are the discrete targets. Okay, now move the data set and we try to visualize through the plots by using the two-dimensional graph. So here I'm just plotting everything step by step. The x-axis is the feature and the y-axis is the discrete target. Before going to the next step, we have to get a clear knowledge about the graph and why we need the graph for the linear regression. So that I'm going to take a simple data set and I'm going to every data points in the graph. In the visualization pattern, you can able to find the meaning that how the each data points are correlated or connected. And as I said, the each data point are considered as a real world example or a real world observation. And there is something called as correlations. If the feature is increases, then the target is also increased. Then it's said to be a positive correlation. If the either feature or target goes up or down, vice versa, then it's said to be a negative correlation. The final one we have to know to move further is about the information of line. In this, we are having three parameters. They are the slope, intercept, and the length of the line. The slope tells how your line is inclined, either downward or upward, and intercept was denoted by C, which means where the line was started from. Initially, consider the slope as 0, that's why the line is flat. As I already said, the intercept value explains where the line starts from the y-axis. Here, consider the intercept as 3.46 and I'm going to move the line and you can see how the parameters were changing. The above equation explains the equation of the line, the same we had studied in our school days. That's why I'm not going with that. Now continue where we had left. Here I plotted the data points. Now we have to fit the best line for the prediction. For that, we have to know the key behind finding the best fit. In machine learning, we are having lots of loss function. Here, the loss function named as mean square error. Here is the mathematical representation of it. The n denotes the number of data points. In our case, we are having 5 data points. The first parameter y denotes the actual price which is in the data set. The y hat represents the predicted price that our line predicts. Still you didn't get it. Just bear with me. I'm just taking a small data set again for the explanation purpose. Here it is not our actual data set. So I just write the equation here and I'm taking the actual and the predicted outputs which is in the equation and I'm going to make the calculation here. Here you may have a doubt that why we are squaring. The legal reason is the distance between the 2 points should not be a negative. If you still didn't get anything, just bear with me again. Here we get the mean square error. The goal of the linear regression to minimize this value. I think you may get some idea about this equation and how it works. Now let's move to the actual code that is fitting the baseline. Here I'm going with our traditional data set. For that, I'm again redrawing the graph with x-axis as rooms, y-axis as prices, and again I'm plotting all the data points. The points are referred from our data set that we have discussed in our dataset section. Step 1, we have to initialize the line. For that, I'm going to calculate the mean of the actual outputs and setting the slope as 0, that we can get the line equation as y equal to 250. The line is drawn in the left side. Now we have to calculate the distance between the data point and the line we had drawn. For that, let's see the error for the particular data point when the input x equal to 2. For the clear explanation, I'm going to zoom a little bit. The blue point denotes the actual output, which is in our data set. The predicted output was 250, which is mentioned by the line. Here, roughly you can see there is the distance between the actual and the predicted output. So I am just calculating the distance between the actual and the predicted data point. The same procedure has been followed over all data points and the distance has been listed here. You can see that the distance are in negative. We know that the distance have to be in positive. That's why we are squaring here. For we get the sum value as 25,000. By the formula of mean square error, I am just dividing it with the number of data points as 5. We get the value as 5000, which explains that our model has the error value as 5000, which is incredibly high. For the better understanding, I'm just going to write this as a table. This is our first iteration. In machine learning lingo, we called as epoch 1. Now, this is our initial state. Now, I am going to move the line little bit by changing its parameters, which is the slope and the intercept. Now, I just move the slope a little bit with the value of 25 and the intercept value is 150. Again, I am going to calculate the mean square error for all data points. For that, we have to calculate the distance between the actual and the predicted outcomes. It's the calculation for that. I taken out all those things and I'm going to square and add it for the total squared errors. After that, I'm going to divide it with the number of data points and then I get a mean square error value as 1250. Again, I'm going to move the line little bit by tweaking its parameters, slope and intercept as 40 and 75. Again, the distance has been calculated. The same procedure has been explicitly followed for the different epochs. In our fourth iteration, we had found our best fit line with a slope of 50 and the intercept as 50. Here you can see the mean square error is 0. It explains that there is no error between the actual and the predicted outcomes. This is the time to use our model for the prediction. Here is the mathematical equation for our line. The x denote the input feature, which is rooms, and y is the price. Now I am putting the input value, which is the number of rooms, as 3.5, and then you can get the price of the particular room, and then you get the price which has been followed for predicting different inputs in the given range. But in our real life, the case is not be that much simple. For an example, here we are having one input feature and one output. What if there are two input features? Then you might think the equation get larger. Yes, it is. And we used to call the slope as weights. And of course, the dimension also changes. I have a question. What if our feature count increases more than 2? Comment it if you find the answer. If you not know about that, don't get panic. And these are the upcoming sessions we are going to conduct. From that, you can get the answers for the each and every question that arises in your mind.